Imagine a place so cold, so isolated, and so vast that for centuries it remained almost entirely beyond the reach of human exploration. A landscape where the horizon disappears into endless white, where the wind carves patterns into the snow that remain untouched for months, where temperatures plunge so low that even metal becomes brittle and machines struggle to function. This is Antarctica. At first glance, it appears to be the most lifeless place on Earth. A frozen desert where almost nothing grows and almost nothing survives. A continent buried beneath an immense shield of ice that has slowly accumulated over tens of millions of years. From space, Antarctica looks like a single unbroken mass of frozen stillness. But appearances can be deceiving. Because beneath this vast and silent ice sheet, something extraordinary exists. For decades, scientists assumed that everything under Antarctica's ice was simply frozen rock, a cold, motionless landscape buried beneath layers of snow and ice thousands of meters thick. A place where nothing moved and nothing lived. But in recent years, a series of discoveries has begun to reveal something far more mysterious. Hidden beneath the ice lies an entire world that no human had ever seen. A world of flowing rivers, vast lakes, hidden valleys, and ecosystems that have been sealed away from the surface for unimaginable lengths of time. And what scientists are beginning to uncover there is reshaping how we understand life on Earth. To understand why this discovery is so extraordinary, we must first understand the ice itself. Antarctica holds nearly 70% of all the fresh water on Earth, locked away in a massive ice sheet that covers almost the entire continent. In some places, the ice is nearly 5 kilometers thick. To put that into perspective, if you were standing on the Antarctic surface above one of these deep regions, the ground beneath your feet could lie deeper than the height of many of the world's tallest mountains. This ice did not form overnight. For millions of years, snow has fallen across Antarctica. Layer upon layer slowly accumulated, compressing under its own weight. Over time, the lower layers of snow transformed into solid ice. As the layers built up, the immense pressure forced the ice to behave almost like a very slow-moving liquid. The entire Antarctic ice sheet slowly flows outward from the center of the continent toward the surrounding oceans. The movement is incredibly slow, often only a few meters each year, but over thousands of years, entire glaciers can travel vast distances. Yet deep beneath this flowing ice, something even more remarkable occurs. As the weight of the ice increases, pressure builds at the base of the ice sheet. The friction between ice and rock generates heat. At the same time, geothermal energy from deep within the Earth slowly rises through the planet's crust. This combination of pressure and heat creates an unexpected result. At the very bottom of the ice sheet, the ice begins to melt. Not at the surface where sunlight touches the ice, but far below, in complete darkness. This melting creates pools of liquid water trapped beneath kilometers of solid ice. Water that has no contact with the atmosphere, no sunlight, and no easy path back to the surface. For decades, scientists suspected these hidden lakes might exist. But proving their existence was extremely difficult. Antarctica is one of the most remote and inhospitable environments on Earth. Drilling through kilometers of ice in temperatures that can fall below -60 degrees Celsius requires enormous logistical effort and specialized equipment. For a long time, the ice concealed its secrets. Then, in the late 20th century, new technology began to reveal something astonishing. Using satellites equipped with radar capable of penetrating ice, scientists started mapping the hidden landscape beneath Antarctica. What they discovered was completely unexpected. The ice sheet was not resting on a flat layer of rock. Instead, beneath the ice lay a complex landscape of mountains, valleys, and basins, a buried continent that looked surprisingly similar to landscapes found elsewhere on Earth. But even more surprising was what filled some of those basins. Liquid water. Vast lakes hidden deep beneath the ice. One of the first and most famous of these discoveries was Lake Vostok. Buried nearly 4 kilometers beneath the Antarctic ice sheet, Lake Vostok is one of the largest subglacial lakes ever discovered. It is roughly the size of Lake Ontario in North America. But what makes it extraordinary is not just its size. It is its isolation. Scientists believe Lake Vostok may have been sealed beneath the ice for more than 15 million years. That means the water inside this lake has been completely cut off from the outside world since long before modern humans existed. No sunlight, no atmosphere, no direct connection to the surface environment. And yet, researchers began to wonder something extraordinary. Could life exist there? At first, the idea seemed unlikely. Life on Earth, as we know it, usually depends on sunlight. Plants capture solar energy through photosynthesis, forming the base of nearly every ecosystem on the planet. Without sunlight, entire food chains would collapse. So how could anything survive in a dark lake buried beneath kilometers of ice? But scientists were beginning to realize that life on Earth can be far more adaptable than once imagined. In the deep oceans, far below the reach of sunlight, entire ecosystems thrive around hydrothermal vents on the seafloor. These environments rely not on sunlight, but on chemical energy released from the Earth's interior. Microbes living near these vents convert chemicals like hydrogen sulfide into energy, forming the foundation of complex ecosystems. If life could exist there, perhaps it could also survive beneath Antarctic ice. This possibility sparked a new era of exploration. Researchers began developing ways to drill into these hidden lakes without contaminating them with surface microbes. The challenge was immense. Not only did the drilling equipment need to penetrate kilometers of ice, but it also had to remain sterile enough to avoid introducing modern life into an ecosystem that might have remained untouched for millions of years. And as scientists prepared to explore this hidden world, satellite data began revealing something even more surprising. Lake Vostok was not alone. Far from it. Over time, researchers discovered that Antarctica contains not just a few isolated lakes beneath its ice sheet, but hundreds of them. Some small, some enormous, many connected through a network of hidden rivers flowing slowly beneath the ice. In fact, Antarctica's hidden hydrological system may rival the great river networks found on the continents above the ice. And the deeper scientists looked, the more mysterious this hidden world became. Because buried beneath kilometers of ice, cut off from sunlight and isolated for unimaginable stretches of time, something appeared to be moving within these waters. Something alive. And what scientists would eventually discover beneath the Antarctic ice would challenge long-held assumptions about where life on Earth can exist. But the most surprising discoveries were still waiting to be made. For decades, Antarctica's hidden lakes remained little more than mysterious shapes detected by radar beneath the ice. Scientists knew they existed, but reaching them was an entirely different challenge. Drilling through nearly 4 kilometers of ice in one of the harshest environments on Earth required technology, patience, and extraordinary caution. Researchers faced a difficult dilemma. If these lakes truly had been isolated for millions of years, even a single drop of contaminated surface water could destroy an untouched ecosystem. Introducing modern microbes might permanently alter a world that had remained unchanged since long before humans existed. So scientists had to develop drilling systems that were not only powerful enough to reach the lakes, but sterile enough to protect them. This led to one of the most careful scientific expeditions ever attempted. For years, international teams designed clean drilling systems that used sterile hot water or specially treated drilling fluids. Equipment was cleaned repeatedly to remove any trace of surface bacteria. Only when scientists were confident that contamination could be minimized did the first true explorations begin. One of the earliest breakthroughs came in 2012. After more than 2 decades of preparation, Russian researchers finally drilled through the Antarctic ice and reached the surface of Lake Vostok. The moment was historic. For the first time in human history, scientists had penetrated an environment that had likely remained sealed beneath the ice for millions of years. But the discovery raised an even bigger question. What exactly was inside? Early samples of frozen lake water were carefully extracted and analyzed. Researchers searched for any sign of life, even the smallest trace of biological material. And what they found stunned the scientific community. Within the samples were fragments of microbial DNA, evidence that life might exist in one of the most isolated environments on Earth. These microbes were unlike anything typically found in ordinary lakes. Many appeared to be extremophiles, organisms capable of surviving in environments that would be lethal to most forms of life. Some of the genetic signatures suggested bacteria that could survive in near-freezing temperatures, under immense pressure, and with no sunlight. But perhaps even more surprising was how these organisms might survive at all. Without sunlight, there can be no photosynthesis. And without photosynthesis, there is no conventional food chain. So where would the energy come from? Scientists began to suspect that life in subglacial lakes might depend on chemical energy, much like the ecosystems surrounding hydrothermal vents on the ocean floor. Beneath Antarctica, water flowing under the ice interacts constantly with the rock below. This interaction releases minerals and chemical compounds into the water. Certain microbes are capable of using these chemicals, including iron, sulfur, and hydrogen, as sources of energy. Instead of sunlight powering life, chemistry does. In essence, these hidden lakes may host ecosystems that function completely independently of the sun. The deeper researchers looked, the more intriguing this possibility became. But Lake Vostok was only the beginning. As satellite radar technology improved, scientists began mapping Antarctica's hidden water system in greater detail than ever before. And what they discovered was astonishing. Antarctica contains more than 400 subglacial lakes. Some are small and isolated. Others are enormous bodies of water stretching dozens of kilometers across. But perhaps the most remarkable discovery was that many of these lakes are connected. Deep beneath the ice, water flows through hidden channels and rivers that link these lakes together. Some lakes slowly fill with water over time before suddenly draining into neighboring basins through unseen pathways beneath the ice sheet. This hidden hydrological system behaves almost like an underground river network, except it exists beneath 4 kilometers of ice. One of the most fascinating examples of this system is Lake Whillans. Located beneath the West Antarctic ice sheet, Lake Whillans lies about 800 meters below the surface, far shallower than Lake Vostok, but still completely sealed beneath ice. In 2013, an international research team known as the Wizard Project successfully drilled into Lake Whillans using a sterile hot water drill system designed specifically to protect the lake's ecosystem. When their instruments finally entered the lake, scientists immediately began collecting water and sediment samples. What they discovered was extraordinary. The lake was not sterile. It was alive. Thousands of microbial cells existed in every milliliter of water. Entire communities of microorganisms were thriving in the dark, cold waters beneath the ice. These microbes were feeding on minerals and chemical reactions occurring in the sediments below the lake floor. In other words, a fully functioning ecosystem existed beneath Antarctica's ice, one that had likely persisted for thousands, perhaps even hundreds of thousands of years. But the implications went far beyond Antarctica, because environments like these may not only exist on Earth. Elsewhere in our solar system, several icy moons appear to contain vast oceans hidden beneath thick layers of ice. One of the most intriguing examples is Jupiter's moon Europa. Europa is covered in ice, much like Antarctica. Beneath its frozen surface lies a global ocean that may contain more water than all of Earth's oceans combined. Another example is Saturn's moon Enceladus. Data from spacecraft has revealed enormous plumes of water vapor erupting from cracks in its icy surface, evidence that liquid water exists beneath the moon's frozen crust. For astrobiologists, Antarctica's hidden lakes provide a remarkable opportunity. They serve as natural laboratories for studying how life might survive in icy environments beyond Earth. If microbes can thrive in dark, cold lakes beneath kilometers of Antarctic ice, perhaps life could also exist beneath the frozen surfaces of distant moons. And this possibility has changed how scientists think about where life might exist in the universe. But Antarctica's hidden world still holds many unanswered questions. How old are these ecosystems? Have they remained isolated for millions of years? Or do slow movements of water beneath the ice occasionally connect them to the surface environment? And perhaps the most intriguing question of all, what else might be living there? Because the deeper scientists explore beneath the Antarctic ice, the more it becomes clear that this frozen continent is not as lifeless as it once appeared. Instead, beneath its silent white surface lies a complex, hidden world that is only just beginning to reveal its secrets. And the discoveries that come next may change our understanding of life on Earth, and possibly far beyond it. And the discoveries that come next may change our understanding of life on Earth, and possibly far beyond it. For much of human history, Antarctica was imagined as a silent, frozen wilderness. A place defined almost entirely by its surface, endless ice, powerful winds, and extreme cold. It seemed like the ultimate boundary of life on our planet. But the deeper scientists have looked beneath the Antarctic ice sheet, the clearer it has become that this assumption was wrong. Far from being a barren continent, Antarctica hides an entire network of lakes, rivers, and ecosystems that have quietly persisted beneath the ice for immense stretches of time. And understanding these hidden systems is becoming increasingly important, not only for biology, but also for understanding the future of the planet itself. Because these lakes are not just biological mysteries. They are also part of a dynamic and powerful water system that influences the movement of the Antarctic ice sheet. For many years, scientists believed glaciers moved primarily because of gravity. Ice accumulating in the center of Antarctica slowly spreads outward toward the ocean, forming massive glaciers that creep across the continent. But researchers are now realizing that water beneath the ice plays a crucial role in this movement. Subglacial lakes can fill and drain over time, releasing water that flows beneath glaciers like a lubricant. This thin layer of water reduces friction between the ice and the rock below. The result is subtle but powerful. Entire sections of the Antarctic ice sheet can accelerate, sliding more quickly toward the ocean. In recent years, satellite measurements have detected sudden changes in the elevation of the ice surface above certain subglacial lakes. These changes occur when lakes fill with water, pushing the ice upward slightly, or when they drain, causing the ice above to sink. In some cases, scientists have observed lakes draining enormous volumes of water, sometimes billions of liters, through hidden channels beneath the ice. This moving water can travel hundreds of kilometers before reaching the ocean. These discoveries are helping scientists understand how Antarctica's ice sheet behaves, and how it might respond to climate change. Because Antarctica contains enough ice to raise global sea levels by nearly 60 meters. Fortunately, such a complete melting of the ice sheet would take thousands of years. But even small changes in the flow of Antarctic glaciers could significantly influence sea levels around the world. Understanding the hidden water systems beneath the ice is therefore essential for predicting how Antarctica may evolve in the future. Yet the scientific importance of these discoveries goes even deeper. Because Antarctica's subglacial ecosystems challenge one of the most fundamental assumptions about life. For centuries, scientists believed that sunlight was the ultimate source of energy for nearly all living systems on Earth. Plants capture solar energy through photosynthesis, forming the base of most food chains. But ecosystems beneath Antarctic ice function without any sunlight at all. Instead, life survives through chemical reactions between water, rock, and minerals. Microorganisms extract energy from iron, sulfur, and other elements released from the Earth's crust. These chemical reactions provide enough energy to sustain entire microbial communities in complete darkness. This discovery is forcing scientists to rethink the boundaries of where life can exist. If life can thrive beneath kilometers of ice in Antarctica, perhaps it can survive in environments once thought to be completely uninhabitable. And that idea is reshaping the search for life beyond Earth. Planetary scientists now believe that several icy moons in our solar system may contain oceans beneath thick layers of ice. Europa, one of Jupiter's largest moons, is thought to possess a vast ocean beneath its frozen surface. The ice shell covering this ocean may be several kilometers thick, remarkably similar to the ice covering Antarctica's hidden lakes. Yet beneath that ice lies a global ocean that may be in contact with the rocky interior of the moon. If chemical interactions between water and rock occur there, much like they do beneath Antarctica, they could potentially provide energy for life. Saturn's moon Enceladus presents another intriguing possibility. Observations from spacecraft have detected enormous plumes of water vapor erupting from cracks near the moon's south pole. These plumes contain tiny particles of rock and organic compounds, suggesting that liquid water interacts with the moon's interior. Some scientists believe that hydrothermal vents may exist on the floor of Enceladus's hidden ocean. If that is true, the conditions could resemble environments where life thrives on Earth. And the lesson scientists learn from Antarctica's hidden lakes may one day guide future missions searching for life on these distant worlds. But even here on Earth, Antarctica's buried ecosystems still hold many unanswered questions. Researchers continue to explore new lakes beneath the ice, carefully drilling into these isolated environments and collecting samples of water and sediment. Each expedition reveals new details about how life adapts to extreme conditions. Some microbes discovered beneath the ice appear capable of surviving with incredibly small amounts of energy. Others seem to rely on complex chemical cycles that scientists are only beginning to understand. These organisms may even hold clues to ancient life on Earth. Because environments like Antarctica's subglacial lakes may resemble conditions that existed billions of years ago, when life first emerged on our planet. Studying these ecosystems could help scientists understand how life began, and how it might evolve in extreme environments. But despite decades of research, the hidden world beneath Antarctica's ice remains largely unexplored. Only a handful of the continent's hundreds of subglacial lakes have ever been directly sampled. Many more remain completely untouched. Beneath kilometers of ice, vast regions of Antarctica are still waiting to be discovered. Entire ecosystems may exist there that no human has ever seen. New species of microorganisms may be quietly evolving in isolation, adapting to conditions unlike anywhere else on Earth. Hidden rivers may still be flowing through unseen valleys beneath the ice sheet. And as technology continues to advance, scientists are developing new tools that may allow them to explore these environments more deeply than ever before. Robotic probes, autonomous underwater vehicles, and advanced drilling systems may one day travel through these hidden lakes, mapping their depths and studying their ecosystems in unprecedented detail. Each discovery will bring us closer to understanding one of the most mysterious environments on our planet. Because Antarctica is not just a frozen wilderness. It is a gateway into a hidden world beneath the ice. A world that reminds us that even in the most extreme and isolated places on Earth, life finds a way to survive. And as scientists continue to explore the frozen continent, one thing becomes increasingly clear. The greatest discoveries about our planet may not lie on its surface, but hidden deep beneath the ice, waiting patiently for us to find them.